Okay, so chapter 6 picks up where chapter 5 left off. Remember, chapter 5 was just looking at categorical statements on their own, and then the standard forms of the categorical statements, how to convert regular categorical statements written in regular language into one of the 4 standard forms of categorical statements. But then this chapter, chapter 6, is going to be looking at how categorical statements can be put together to form an argument, which we call a categorical syllogism. A syllogism is just sort of a fancy name for an argument, or just sort of a style of reasoning, a pattern of reasoning, an inference to be made, a conclusion to be drawn from specific premises. That's just what a syllogism is supposed to be. So a categorical syllogism then is an argument in which a categorical statement is the conclusion that's based on or derived from 2 premises, where the premises are both categorical statements themselves. So just as a reminder, here's the 4 standard forms of categorical statements. And for this presentation, I'm going to present all of the premises and conclusions involved in these arguments in their standard form already. But for homework or quiz or test or whatnot, you may have to convert the statements into one of the 4 standard forms before you start assessing whether the argument that's involved is deductively valid or not, because that's the ultimate goal of what we're doing here, is trying to figure out if these categorical syllogisms are deductively valid or deductively invalid. Okay, so here's a couple of examples of categorical syllogisms. It just so happens that these ones are deductively valid, so these are the deductively valid examples of categorical syllogisms that we're going to be dealing with here. And so we'll come back to these. And here's the 2 examples of deductively invalid categorical syllogisms. And again, we'll be coming back to these. So the point here is to use what's called the Venn diagram method of figuring out whether these categorical syllogisms are deductively valid or invalid. So for a categorical syllogism to be deductively valid, it has to be impossible to draw a Venn diagram that satisfies both premises, but then not the conclusion. So there might be a variety of ways to draw a Venn diagram that satisfies what's going on in a categorical statement or a categorical syllogism. But if it's impossible to draw a Venn diagram such that both premises come out true, but the conclusion comes out false, then you know you've got a deductively valid categorical syllogism. So some of you have probably seen Venn diagrams before, but using them for categorical syllogisms, here's some examples. So these are kind of standard types of Venn diagrams. The textbook uses an interesting method of drawing out Venn diagrams that we'll get to later. But outside of the book, you might see Venn diagrams that look like this. So all S's are P's. So this circle with the S in the middle represents the S's, whatever they might be. And this statement, all S's are P's, is represented here because the circle representing the S's is completely contained within the circle representing the P's. So all the S's are contained within the P circle. Alternatively, here, no S's are P's. So the S circle, the circle representing all the S's, is completely outside of the circle representing the P's. So there's no overlap here at all, so we know that there are no S's or P's. But if, on the other hand, some S's are P's, then the S and the P circles can overlap. So that's at least some, or maybe even just one S, it belongs in the P circle. So some S's are P's. But then over here, interestingly, in terms of the circles, it's kind of the same thing, but I moved the S just to make it clear that this last one in the bottom right is showing that some S's are not P's. Some of the S circle is outside the P circle. Not all of it, but some of it is. Okay. So how can we use these to represent categorical syllogisms? Well, let's look at the emeralds are gems example that I had before. And I mentioned before that this is going to be a deductively valid argument. So let's see how that works out. So the first premise says that all emeralds are gems. And so the emeralds circle is completely contained within the gems circle. Then we want to represent the second premise, the second categorical statement as a premise here, that some rocks are not gems. And so the rocks circle, at least some of it, has to be outside the gems circle in order to satisfy this second premise here. And I drew it in a way that kind of matches our common sense understanding of rocks and gems and so on. That is that all gems maybe are rocks. We could have maybe put this a little bit of the gems circle outside of rocks. There might be some gems that aren't rocks. But nevertheless, this definitely satisfies, this way of drawing this Venn diagram satisfies the two premises. But then notice what it does for the conclusion. Some rocks are not emeralds. Is that shown in our diagram? It sure is. And in order to draw this in such a way that the conclusion would turn out to be false, so the conclusion says some rocks are not emeralds. In order for that to be false, then it would have to be true that all rocks are emeralds. Well, we can't draw it that way and still satisfy the second premise that some rocks are not gems, because in order to make the conclusion turn out false, the rocks circle would have to be completely contained within the emeralds circle. And that would be a violation of the second premise. So since it's impossible to draw this diagram in such a way that satisfies both the premises, that is, where both of the premises turn out to be true, but then at the same time the conclusion turns out to be false, since it's impossible to draw a Venn diagram that does that, this tells us that this categorical syllogism is indeed deductively valid. Okay, let's look at the next example. Oh, well, actually, first, here's an alternative drawing of that first example. We could have drawn it this way, right? Some rocks are not gems. We could have put the rock circle completely outside of the gems circle. Now, that doesn't match sort of our common sense understanding of the relationship between rocks and gems. So maybe this one's a little more confusing or a little less obvious of a way to do it. But nevertheless, just in terms of satisfying what it's saying in the premises there, this diagram shows that both those premises turn out true, right? So all emeralds are gems. Yep, the emerald circle is completely within the gem circle. Some rocks are not gems. Well, yeah, the rocks circle is completely outside the gem circle. So that matches the second premise. Some rocks are not emeralds. Well, yeah, the rocks circle is completely outside the emerald circle. So this one shows that how we have a different way of drawing this Venn diagram where both premises turn out to be true, and then also the conclusion turns out to be true as well. So again, deductively valid. All right, now let's look at the next example. So no birds are mammals. Well, that means that we have to have no overlap between the birds circle and the mammals circle. So that's what we've got here. None of the birds are in the mammal circle. Okay, now all bats are mammals. Well, that's going to have all of the bats inside the mammals circle. So now we've got a Venn diagram that matches the two premises. Now we look at the conclusion. No bats or birds. Well, that's what we've got. The bat circle is completely outside the bird circle, of course. And there's no alternative drawing of this that could satisfy the two premises, yet have the conclusion turn out to be false. So this shows us that it's a deductively valid categorical syllogism. Okay, now on to the deductively invalid categorical syllogisms. For these, it is possible to draw a Venn diagram that satisfies both the premises, but not the conclusion. So here's a simple example. All butterflies are insects. Well, okay, so the butterfly circle is completely contained within the insect circle. Then some animals are insects. We're going to have an animal circle that at least partly overlaps the insects. So here we've got it. Then all animals are butterflies. Oh, that would mean that the animal circle is completely contained within the butterfly circle, and we can't do that and have the two premises come out as true. So we've drawn a Venn diagram that shows, that matches the two premises, that shows that how they can be true, but the conclusion's false, because it just doesn't get matched by this Venn diagram. So we successfully drew a Venn diagram that satisfies the two premises, but not the conclusion. So that indicates to us that this is a deductively invalid categorical syllogism. Okay, let's look at this next one. So no Corollas are Toyotas. Doesn't really matter what Corollas and Toyotas are. You don't have to know about this car manufacturer. You just draw the diagrams to match the premises. Okay, so the Corolla's circle is completely outside the Toyota's circle to match this first premise. Then all Toyotas are automobiles. Okay, well then the Toyota circle has to be completely contained within the automobile circle in order to satisfy the second premise. Now then we take this diagram and see how it matches our conclusion. Some automobiles are Corollas. Is there overlap there? No. So we were able to successfully draw a Venn diagram that satisfies the two premises, but not the conclusion. So this indicates to us that this is a deductively invalid categorical syllogism. Okay, so that's a common way of using Venn diagrams. That's the way I learned it, and so that's the way I commonly do it. But I'll go through the way the textbook does it, because it actually does it in a very systematic, standardized way, where there's a little less creativity, perhaps, in how you can draw your circles. Okay, so first off, if we're just looking to draw a single statement using the textbook's method for Venn diagrams, they start off like this, just two overlapping circles. One of the circles is going to represent the subject, one of the circles is going to represent the predicate. And we can use this basic thing here, this basic diagram, to represent all four of the standard categorical statements. And so here's what they would look like. All S's are P's. Well, what we do is we shade out the part of the S circle that does not overlap with the P circle to show that nothing can go in there. So this shading kind of blocks anything from being put into this part of the S circle. So the only part of the S circle that's available is the part that overlaps with the P circle. So this matches what's meant by all S's are P's. Over here, no S's are P's. So in this case, we shade out the part of the S circle that does overlap with the P circle, so to show that nothing can go in there. No S's can go into the part that overlaps with the P circle. So the only place available is the part of the S circle that's outside the P circle. So no S's are P's. Down here in the bottom left, some S's are P's. So we put a little X in the overlap part there. This X represents some individual thing, some individual S that is a P. There could be more than one S that's a P, and there even could be some S's that aren't P's. But this is just making it clear that there's at least one S that is a P, and that thing, whatever it is represented by this X. So some S's are P's, that is, there's an S that is a P. Over here, some S's are not P's. So we put an X representing some individual thing that's an S, but is also not a P. Now, it could be that some S's are P's. We haven't shaded out this overlap area here, so it's possible that something could go in there. But this categorical statement is just simply saying that there's at least one S that is not a P, and that's what this X is showing us. Okay, so that's the four standard categorical statements using kind of their simple standardized Venn diagram system here. And so let's look at how this works for categorical syllogisms. Well, it's slightly more complicated. We start off with 3 overlapping circles in this way. And each circle represents either a subject or a predicate, because remember, in any categorical syllogism, there's only 3 things. There's 3 items. So let's take a look at this. In this case, the 3 circles are representing emerald, gems, and rocks. So all emeralds are gems, says the first premise. So we shade out all the parts of the emerald circle that does not overlap with the gems circle. So the only place that anything is available to go is in the part of the emerald circle that overlaps with the gem circle. So all emeralds are gems. Okay, then the next premise tells us that some rocks are not gems. So there's at least one rock, which we represent with this X here, that is not overlapping with the gem circle. So it's in the rock circle, but not in the gem circle. So here it is. So some rocks are not gems. All right, now we've represented the two premises here, and so we can move on to see how this diagram represents the conclusion. Some rocks are not emeralds. Okay, so our X here that we already put in, is it overlapping with the emerald circle? Well, no. So we've got a Venn diagram that satisfies both premises and the conclusion. And there's no other way to set up this Venn diagram such that it would satisfy both of those premises. But then when we do set it up to satisfy the premises, the conclusion is automatically satisfied as well. So this shows us in a systematic, standardized way that this is indeed a deductively valid categorical syllogism. Okay, let's look at our other examples. So now we've got the three overlapping circles representing bats, birds, and mammals. First premise tells us that no birds are mammals. So we shade out the whole part of the birds circle that overlaps with mammals. So the only birds part of the birds circle that's available is the part that's outside of the mammals circle. So this shows us that no birds can be mammals. Now, all bats are mammals. So that means we have to shade out all the parts of the bat circle that do not overlap with the mammal circle. So the only part of the bat circle that's available now is part of the part that does overlap with the mammals circle. Then we look at our conclusion. No bats or birds. Is that represented in our Venn diagram here? Yes, the only part of the bat circle that's available actually does not overlap with any of the bird circle. So this shows us that we've got a Venn diagram that satisfies both premises and also automatically shows that the conclusion must be true as well. And there's no alternative drawing of this Venn diagram that would satisfy both those premises. So we know that we've got a deductively valid argument. Okay, let's look at the invalid ones. In this case, it's going to be possible to draw a Venn diagram that satisfies both the premises but not the conclusion. So all butterflies are insects. So we shade out all of the part of the butterfly circle here that does not overlap with the insect circle, so that the only spot of the butterfly circle that's available is the part that overlaps with insects. So this shows that all butterflies must be insects. Then, second premise, some animals are insects. So we can put that right here. Some animals, at least one animal, right, represented by this X, that's inside the A circle, the animal circle, is also inside the insect circle. So some animals are insects. Now, all animals are butterflies is our conclusion. So is that represented here? Well, no. Some animals, in fact, most of the animal circle is outside of the butterfly circle. So this is available. Something could be included down here somewhere. So this shows that the conclusion can be false. So although this Venn diagram shows both premises being true, we've got a Venn diagram that also shows that the conclusion could be false. So this indicates that this is a deductively invalid categorical syllogism, because it's possible to draw a Venn diagram that satisfies the premises but leaves the conclusion as false. Okay, let's look at the car example now. No Corollas are Toyotas. So the part of overlap between Corollas and Toyotas is shaded out. Nothing can belong there. So all the Corollas are not Toyotas. So no Corollas are Toyotas. Then all Toyotas are automobiles. Well, then we're going to have to shade out the part of the Toyotas circle that does not overlap with the automobiles. Then, so that satisfies the premises. And now when we get to the conclusion, some automobiles are Corollas. Well, we've got a bunch of the automobiles circle here that's available that's outside the Corollas circle. So an X could go into any of this area down here, which would make the conclusion be false. So we've got a Venn diagram. It's obviously possible to draw a Venn diagram where the premises are true, but the conclusion could be false. So this is a deductively invalid argument. Okay, so that's sort of the basic Venn diagram method for determining the deductive validity or invalidity of these categorical syllogisms. And I just couldn't help but notice that their standardized Venn diagram form kind of reminds me of the symbol that's on Thor's hammer. And anyway, that's enough for now.